Today I will show you something about Class C oscillators. First, let's look at the schematics. There are several schematics here. This schematic shows a vacuum tube Tesla coil. It's very common on YouTube. As you can see, it uses a triode here, and this is the main LC resonant tank circuit. You can call it a tank circuit. And the capacitors here, you'd better use these kind of capacitors, ceramic capacitors, high voltage. This one 15 kilovolts, 500 picofarad. And because I don't have the nut, I have only 2 pairs of nuts, so I can just use one capacitor. So I use another kind of capacitors. It's also ceramic capacitors, like this one here. You can see this one. I have 5 like this one. You can see it's made in China, and it says it can work at 10 kilovolts, and the capacity is 100 picofarad. And the red one here, the same size, but the capacitance is 220 picofarad. This one here. So let's come back. I made these 2 circuits yesterday afternoon, but I found that they resonate at a lower frequency than these schematics. The resonant frequency, this one, is about 500 kilohertz. That's not I want, because the low frequency arcs looks like some lightnings, but I want an arc that looks like a flame, a real flame. So I chose this circuit, and finally I made this one here. First of all, you can see we need a high voltage supply, which I used a microwave oven transformer here. The input voltage is one phase 230 volts here. It is read on this meter here. Let me focus it. 230 volts. And it says 2 amps. But this meter reads the total current here and here. So the mains voltage comes from this wire to this variac, and you can see I turn it to around 60 volts here, and the output voltage through here to the primary coil of this high voltage transformer here. And the secondary coil I measured now has an output voltage at around 500 volts, 500 volts AC into this high voltage diode in series with that. This one, aluminum coated capacitor, high voltage capacitor. It's a micro oven capacitor here, 2100 volts and 1 microfarad. Just a half bridge rectifier. And let's go back to the schematic. The high voltage comes in here and through a choke. In my case, I use a Tesla coil secondary coil because I don't want to make another choke here. You can see this here is a high voltage positive terminal and this is a negative. The positive through this choke into this choke here is 60 turns on a 32mm diameter PVC water pipe and comes out to that end. That end is here to the vacuum tube's anode here and to the resonant coil. The vacuum tube I use is a Chinese made FU50 vacuum tube. I have another one here. You can see I have lots of, let me turn on the light. Okay, now you can see many tubes here and there and here, and here is a very large vacuum tube. It's rated at 15 kilowatts. I have two, this one, and there is another one here. The many amplifier tubes which is used on TV transmitters, AM transmitters. Okay, this one here is a FU50. You see, FU50 vacuum tube. The same as I used here, this tube. Okay, now let's talk about it. You can see the great leak resistor here. I use a 25 kilo ohms resistor here, and this is the resonant capacitor which I uses 133 picofarad capacitor in series with another capacitor we talked about. It's a 220 picofarad capacitor. High voltage capacitors both can work at 10 kilovolts, and you see the circuit connected to the resonant circuit here, coil here, and you see that's very simple. The capacitor in series with one resistor. In this case, I use a 20 kilo ohms resistor. I calculated that this is the best resistor, but I don't have that, so I used a 33 kilo ohm capacitor here, and this is a 27 kilo ohms resistor. I said sorry, 27 kilo ohms resistor here is a great leak. Is this great leak resistor? Very simple circuit, but works fine. You see that one is a fluorescent light. I use it into the coil to test this circuit. But what I want to make is a flame circuit. Is a circuit that oscillators oscillate and can burst out a plasma flame. Why I don't make that circuit? Because this is our dormitory. You see, I am a university student, and here is our dormitory. And our dormitory has a rated power supply about 440 watts. So that power doesn't allow me to make that circuit. So I plan to bring some of these very big tubes home on July 23rd, and after I come home, I will start my plan to make some kilowatts plasma flame. Use air-cooled vacuum tubes, and I have a small vacuum tube here. It can generate about 400 watts RF power. It's a FU 250F. And I found a very interesting thing is that, you see, I use FU50 vacuum tubes here. If you want to make this circuit, you can use GU50. I found that that tube GU50 is the same as FU50, because this I don't know how to say that. My English is not good. This is a Chinese made tube, so Chinese people call it like that. In American or some other countries, they call it GU50. GU50, you can easily buy it with low price. So that's why I use low price tubes to test this circuit. You see the fluorescent light is shining here because the 50 Hertz AC frequency. And I made a high voltage meter here. Use a 250 volts meter and some resistors to divide the voltage divider. I don't know that if that is a true name of this thing in English. And you see, I use 2 vacuum tubes to make an audio amplifier here, and oscilloscopes here, a transformer power supply to that audio amplifier, and here is a SWR meter to measure the transmitter. Here is a JRC, Japanese made JRC. I show you it. JRC SSB transmitter. The transmitter, the antenna current, SWR meter, and outside of our dormitory. I will see you in less than 1 month, and thanks for your watching.